Something else, switching context. I mentioned van der Lande, right? They're building baggage handling systems. This is one baggage handling system, right? So you drop your luggage off at the check-in counter, and then it goes off into the bowels of the airport. And these are the bowels, right? So conveyor belts that move bags to screening machines over here, right? So that check, X-ray the bags for any dangerous liquids, for example. And then move them on, right? Maybe they need to be stored before they go to the airplane because you arrive 3 hours before the airplane leaves. So it's an automated system that has to run. And this is the performance spectrum of a baggage handling system. Well, I have to say it's of a baggage handling system in a stress test, right? So we kind of pushed it to the maximum to kind of see how it behaves. So what do you see here? So this is kind of a path, typical path of bags from check-in to in the middle of the system, right? So all that come in order. Yeah, it's first in, first out. It's no surprise because it's conveyor belts, right? So it's good. It's good that it behaves this way. No, obviously, right? Because you don't have that in the business process. There, things overtake each other. Here, strict first in, first out. So, but there's more to see. Yes, this is a very long delay, right? And you can, this is how it can go, right? That's the speed how which the bags can travel over this. This is much longer. So this is bad. This means somehow the conveyor belt here stopped. And then it took quite a while until it moved on. So you would like to detect this, right? So how can you do this? Here's a simple technique, right? So again, this is performance spectrum. There's two detectors. One is if you have an increased load in a particular area, because if you're overloading your conveyor belt and you're kind of clogging things up, right? Just like traffic jam, too many cars on a road lead to a traffic jam. So just moving a time window over this, counting the number of bags in the time window. If you exceed a certain threshold, and it's difficult to set that threshold on kind of revealing what's meaningful. But you can, then you have a time window in which this is a high load period. I can label these bags in that part to be part of high load. And for these extra long delays, you can use the Z-score, right? So it's extreme deviations from the mean. They exceed a certain threshold, and you can label them as we call it a blockage. And typically in such systems, you have multiple bags caught in a blockage, not just a single one. Okay, so we can detect these, but there's more to see in here if you look very closely. And this is your next level of multidimensional thinking. Who sees it? Okay, yeah, okay, good spotting. That is because, right, so conveyor belts also merge and divert, and here I'm just plotting out one sequence. So this is a spot where bags went a different route, and don't show this in this diagram. So definitely relevant to keep in mind, because the moment we plot as this dimension, certain things we can't see anymore, as we're becoming blind to some parts. But there's something else to see here. The delays follow the traffic jam, right? Here, I have a delay here, and you see here, it's less dense, and the lines are getting longer. Also here, so there's some form of propagation going on. If you think of it, right? You have a conveyor belt, bags are moving. You stop this conveyor belt. Well, there was a conveyor belt before that was moving the bags there. These bags can't go there anymore. If you have what's called a divert, right? So you can route the bags around, things will flow fine. But if not, then this one also has to stop and on. Right? Just like a traffic jam. If you block the road, things will queue up. That's what you see here. You can also detect this. So this propagates, right? And it's not just propagating once, a second time, right? So there's this blockage that propagates, then behavior resumes, and then it propagates again. So this is systematic, and of course this was important to find because this was a stress test, so it was good to detect this. But can we extract this from the data? Yes, we can. The idea is extremely simple. So, some slide is missing. All right, the idea is extremely simple. What we do is we make each pattern, we encode it as a node. So we create a new node, a high-level event node. We create a graph now, and we say, okay, this node here relates to all these observations underneath, right? So we have a lower level log of all the movements of the bags, and we have a higher level event that connects to all these. And then whenever these patterns overlap in time, right? So that you see the overlap in time, but also they connect to each other because they connect on a physical segment. Then we draw an edge. Then we can get these paths or graphs, can enrich this with further information. So these are these kind of outlier cascades that we can detect, where you can see. So this is a blockage. This is high load, and you can. This is hard to read, right? So this is where kind of you need to start thinking differently. So you see here there was a blockage over here, which then later on led to a high load over there because bags couldn't move through this part. Another part of the system was used, and it's outside of this part. Here's a blockage that propagates that you see. And we have additional information that's being added from sensors of the system, right? A kind of equipment reporting sensors that might indicate what's the reason why a conveyor belt, for example, stopped. So these are not process models. These are essentially, each of them is a short trace in the system, but not of a bag, of a higher level dynamic that propagates. Underneath, there's many things that are happening. Mind-boggling, but I wanted to show you what's possible. Okay, first part is done. So I've shown you how this super simple idea of mapping out how items move over consecutive steps in the process, and kind of just drawing it out allows you to see things that you usually don't see if you just analyze the flow of each individual item. Yeah, so intercase dependencies, and it indicates mechanisms that are not part of your model so far. Batching rules, priority rules that's to skip, these conveyor belt dynamics of blockage propagation. And it gives you an idea of what to look further for, right? What to ask in the organization, the stakeholders. But the key thing to get there is what I've written here first. Look at multiple things at once, right? So then I've shown you one way of doing this. Look how to look at multiple things at once. So now we want to look at, okay, I promised you tools and data, right? So this is implemented. We have a prompt plugin. We have a standalone tool that you can use. We also now have a Python implementation that really allows to kind of work in Jupyter notebooks with this performance spectrum. The batch detection, cascade detection, prediction is all implemented. And you can apply this on any classical event log. That's a nice thing, right? You don't need any special data. You can just start right away. Sorry, say again? Yeah. So by default, right? So if you, for example, have a loop over here, then you would see cases going here, and then kind of the line stops and returns over there. I think Vadim at some point also tried to kind of indicate this jump back, but then it gets very clogged. So definitely one of the things to look further, right? If the dynamics are important over looping, you can also unroll, right? You refine the activity labels A1, A2, A3, then you split them out. So brings me back to the spirit of this tutorial, right? So these are ideas, and feel free to pick them up and to adjust them for their own research, right? We hope they're simple enough that you can do this. So that's the idea.